let's go ahead and open up the course syllabus and everything too, because this being the first week of class, I think that's probably the thing that most people are going to actually want to ask about, since we've had this is like the first day of class. So welcome everybody to the physical science lecture for term 5 of 2023. I am, well, the instructor for this course, and I have here your syllabus for the lecture course. My name is Dr. Sanders. I'm an associate professor of physics at Troy University. I am situated at the Troy main campus in Troy, Alabama. And this is the physical science online lecture. I'm going to skip kind of the background bio. I don't know how many people actually read that or whether you're at all interested in it. I don't normally put that stuff in a syllabus, but they said that I should for an online class just because you don't necessarily get to interact with me face to face very often. But it is what it is. What is this course about? Well, it is a general studies course for those of you who are basically non-STEM majors. It is basically a mix of physics mostly, and then some chemistry. There is obviously a bit of overlap between the two, and so it could fairly be said to be like 90% physics and 40% chemistry or something like that. Is because there are entire topics that are a bit of both. Like the entire first chapter on measurements is valid for both physics and chemistry. The entire chapter on thermodynamics is something you'd study in both physics and chemistry, and so on. So it is not going to be especially high level physics or chemistry. It is, I think, at a slightly higher level than what you got in physical science in high school, which is good. This is not a high school class. It is a college class, although there are often dual enrollment high school students in it. So hopefully you find it to be challenging enough to be worth the time to have taken it, but also easy enough that you do well in it. I basically, for you all as online students, I expect you to be reading the chapters that I assign each week, and there is basically one chapter per week for the lecture. There are homework problems and example problems in the notes. I want you working through those. Look through the lecture notes, watch the lecture videos that I give you. You can participate in discussions as appropriate. Sometimes people will start a discussion in the course discussions forums, and you can use those to ask me questions, but also you can use them to ask each other questions. And I hope that you do all at least read them and maybe sometimes respond to them as appropriate. All right, so there's not really any formal prerequisites to this course, although you do also have to have a physical science laboratory course. But as I said before, it is a university course. It's being offered at the university. It's not unreasonable for us to expect you as university students to have some sort of knowledge prior to showing up to this course. I don't expect calculus out of people. I don't even really expect high-level trig and math analysis, but you had to take math through algebra 2 and basic trigonometry in high school in order to graduate from high school for the most part. So it's not that unfair to expect a little bit of rudimentary math background. Um, and the better you are at doing the math side of things, in some sense, the easier this course may end up. But it is not a math course. It's kind of akin to saying that if you're going to take an English literature course, that the background assumption is that you know already when you walk in how to read, how to write, and how to speak English. Okay. Um, are those things listed as prerequisites to the course? No, not necessarily. But we do expect you to know how to do those before you start the course. We wouldn't expect a um, person to walk in and say, I don't speak a word of English, but there's no prerequisite that I speak any English in order for me to take this class. That's just not how we're set up here. Um, so math for us as physicists and chemists and so on, for physical scientists as it were, is our language. So we expect you to speak a little bit of that language at least. The textbook for the course is an Introduction to Physical Science 15th edition. I have it right here on my shelf. This is the 15th edition, Introduction to Physical Science. This is the book that I am using this semester. You may buy the book from the bookstore. It's not, unfortunately, a hard copy, so it's a little hard for me to put back on the shelf. But you may buy that book from the bookstore. You can also choose to get a Cengage subscription. If you go over here to the announcements, um, there's the WebAssign and the ebook announcement. And you have some class key for it, which should work. Once you have done WebAssign, then that basically gives you access to the version of that textbook. So you can choose whether or not you want to buy the textbook or the WebAssign or both. The WebAssign is only for practice. You don't have to have it. It just allows you to practice the homework and then get instant feedback on all the problems. If you choose to work the homework problems out of the book, then you have instant feedback in the sense that the answers are given kind of in the back of the book, so you can go check them. So you work the problem, then you go look and see whether your answer is right or not. Don't just write down the correct answers. That's not a very good way to study material in general. It's even less good for physics, for physical science even, because I can always change like one number in the problem. And if you know how to work the problem, then that one number changing shouldn't cause you any difficulty. But if all you did was write down the answer, your answer is now going to be wrong. For the attendance policy, look, this is an asynchronous class. Case in point, I'm currently holding my first discussion session of the semester, and there are 0 people actually here besides myself. This is not a requirement. You're allowed to miss these. I do hope that you watch the video recording afterwards, especially since I'm sort of required to make these video recordings on occasion. It'd be kind of sad if I'm having to make all these and then they go on to the internet or onto YouTube or what have you, and then 0 people watch them either. But I guess it fulfills some law, some rule of the university. So if nobody watches, then I'll be a little sad, but it won't really affect your grade other than that you might miss information. But I'm trying not to provide crucial information in these that you can't get from my, from at least the recording or from reading the book or what have you. The way that I'm grading this class is that I have quizzes, an exam, and then discussion. And Basically, the exam is the only thing that's proctored. The quiz is 65%. You have one a week, usually due on Saturday. You have one exam that becomes available during the 6th week, and you have 2 weeks to complete it. It is proctored, so you have to set up a proctoring thing. And then the discussion is that basically the introduce yourself to the class assignment, which is largely for attendance, but I do make it worth 10% of the grade. The grading scale is a little different than what you're probably used to, because 85% is enough for an A in this class, although you do need a 75% for a B, 60% for a C, and then 50% to get a D. If you're below 50%, then you really have failed the class. One rule that I have is you have 2 weeks to do this proctored midterm. It only covers stuff up through week 6. So there's no reason why you should have to wait until the middle of week 8, basically the end of when it's due, to set up your exam. Frankly, you should be scheduling it for like the end of week 6 or the beginning of week 7. And then if something comes up, you can always reschedule, and you still have days left within that window to reschedule it in. And you don't even actually have to tell me that you missed the original day and rescheduled it. As far as I know, you took it when you were supposed to, as long as you took it during those 2 weeks. Now, after those 2 weeks are up, there's nothing more you can do to schedule it. So I have an alternative non-proctored midterm that you can take after this window is over for partial credit, but the partial credit is set low enough, and the rules here are set such that you can't take that thing and make an A in the course. If you've decided to not take the proctored exam, you don't earn an A in physical science. You can still earn a B, though. In the event that you do take the proctored exam, the alternative one is basically going to count as like bonus points that we can add back to your midterm grade. The grading timeline that I basically follow here is that if you take a quiz on Canvas, including the exam, then Canvas kind of automatically grades it. And I've tried for some questions to send automatic feedback. Like if it's a multiple choice question, then I can kind of give feedback for every possible answer, or at least I can tell you, how it was that I came up with the answer, how the book came up with the answer if I pull it out of the book, something like that. And if it's automatic, then you basically just get it as soon as you submit it. If you do have further questions, you can email me, and I try to get back to everybody who emails me within 1 to 2 business days. The only time when I don't is if I am gone at a conference, and even then I still try to, or if I have an unusually large volume of these questions. And that doesn't happen very often. So usually within 1 to 2 business days, I get back to you. I do ask that if you ask me for a further feedback, that you specify which quiz it is. And since most of you are also in my lab, that you specify, lecture quiz, 3 or whatever. And please note that if you ask that and then I go look at it, odds are pretty good that the feedback you get is going to be in the form of a comment on that question or on that quiz. Okay. Now, the other graded assignment is the introduction forum. You're supposed to be completing that this week or within a day of adding the course. And essentially, I'm trying to get all those scored fairly early in the first week. And then I'll look at them again towards the end of the second week in case people have added late and scored late. After that, it's so far past due that I will grade it, but I'm in no particular rush. Essentially, I treat it as if you took until the fourth week to do an introduction form that you were supposed to do on day 1 or 2, that you're just not in that much of a rush to get it done and therefore to get it scored. And therefore, there's no reason for me to rush to get it done and scored. It'll get scored when I compile grades, probably. Okay. What else? I've already talked a little bit about the homework. I've already talked a little bit about the exam and quizzes. Basically, I will drop some quiz grades. There is a timer for 90 minutes on these quizzes. And once you start the quiz, the timer starts running. And once you reach the time limit, it submits the quiz for you. Or you can submit the quiz yourself. So if it crashes and it takes you 15 minutes to log back in, well, the timer will have run for those 15 minutes. If you log off and go do whatever it is that people do when they log off in the middle of a quiz and come back 45 minutes later, 45 minutes of that timer will have been used up. So the moment you start the quiz, the timer starts and it stops 90 minutes from that moment. You really should be completing these things at the end of each week. There is a basic late penalty that I put in place. Essentially, due date is Saturday. If you turn it in Sunday morning, I won't have looked at the quizzes by Sunday morning, but it is late. And so, maybe you get a 20% penalty, sort of your score is reduced by 20%. If you turn it in like Monday morning before I've really checked the grades and posted the solution, or really before I've posted the solutions, then the penalty goes up a little bit. And if I post the solutions, then you basically get a pretty substantial penalty because hypothetically people have the solutions. And after more than a week, you've kind of run out of time to take these quizzes unless you made some special arrangements. So do them. Please do them on time. What are we going to cover in this course? Well, we're going to cover chapters 1 through 8 and chapter 11 from your textbook. Okay, so this is a tentative list of the basic topics that we will go over. This week we're covering chapter 1, that is nature of physical science, scientific method, measurements and interpretation, units, dimensional analysis, conversion factors. That's basically what we're doing this week. Next week we get into theory of motion, projectile motion, description of motion, that kind of stuff. Following week it's Newton's laws and so on. I'm not going to sit here and just read this list to you. You can read it yourselves. That is basically it for the syllabus and for my expectations. So hopefully that makes everything clear to you all. And I think since nobody is here, that I'm going to kind of end this part of the meeting. And if you're watching this asynchronously after I've posted the recording, then hopefully you found this to be helpful. Yeah, thanks everybody who is watching. So let's